next will be the mode. Do we have any other explanation? No more. So that's it about median. So mode, what is mode? The mode is the most commonly occurring value in the data series. So basically it's just the high number that come out with the highest frequency. Okay, for example, if I have a look at this data, I have 1, 6, 3, 7, 8, 5. Okay, so does any of the number actually repeat? None of them repeat. One come out once, and also once. So therefore, there is no number that has the highest frequency. All frequency is equal 1. So therefore, mode does not exist. It is possible. It doesn't mean that all data set has mode. Mode could also be non-existent. So for the second example, so I have a data set of 1, 6, 3, 7, 8, 3, 5. If you notice, so in this data set, the number 3, it come out twice. So the rest of the number come out only once, but this one come out twice. So therefore, the mode is going to be number 3. So because it come out the most. And the C, if the data set are 1, 6, 3, 7, 3, 8, 7, 5, 3, 7, if you notice. So 3 come out 3 times. 7 also come out 3 times. So therefore, the mode is both 3 and 7. So there could be no mode at all. Could be one mode, could be more than one as well, depending on the function itself. Okay, so properties of mode. So we use this when we want the most typical case. So we want to know for what case is the highest frequency. So the mode can be used when the data are nominal. Okay, so this is going to be for qualitative data. And the mode is not always unique, meaning that there could be more than one number. Could be more than one, which is being translated in the third example. Could be more than one. And a data set can have more than one mode, or the mode may not exist for a data set. So that is being shown in example number A. Okay, by using this central tendency value, which is mean, median, mode, we can actually figure out what is going to be the distribution of our data set. So according to the rule of thumb, so when your function is symmetric, so the value of mean is going to equal the value of the median is going to equal the value of mode. So all those values are going to be the same. You're going to come out with a symmetric data, bell-shaped data. So if your mean value is greatest, followed by median and mode, so your graph is going to be positive or right skew. Why is that so? Because remember, mode means that you have the highest frequency, and on this side of the graph, so this is actually frequency, and the mode over here, it's the smallest value. So our number on this on the horizontal axis, so it's going to increase when we go towards the right. So therefore, mode, the one with the highest frequency, is going to be here. So that is why as you go towards the right, so your graph is going to taper off. Taper off in Malay is become landai. Okay, so that is why it's going to be right skew. And for the case of left skew, so what happened is that the mean is going to be less than median, and the mode is going to be the highest value. So it's going to be the same idea. So this increase as you go towards the right, and mode is going to be the highest value. The data with the highest frequency is going to be towards the right. So therefore, your graph is going to taper off towards the left. So that is going to be called as negatively or left skew data. Okay, however, in reality, so this is not always going to be the case. If you come across something like this, then yeah, you can actually identify whether it's going to be symmetric, right skew, or left skew. But sometimes median can actually be greater than mode or mean value. If you notice in these three situations, in these three scenarios, median is in the middle. That is not always the case. Okay, the shape of the distribution may be identified by observing the position of the mode value. But the mean and the median, it could be interchanged. The position is, however, we only have to observe the mode. What does it mean by that? For example, let's say if I have a case like this, I have that my mean, so the median value is less than the mean is less than the mode. Okay, so according to what we have up here, so the mean is going to be left skew if the median is the smallest one, if the mean is the smallest one. But here the median is less than mean. So how are this going to be classified? And this is still going to be left skew, because how are we going to decide on that? So we're going to decide on that based on the mode value. So when I sketch this, so my mode value is still going to be the largest value. So my graph is still going to taper off towards the left. So this is still going to be left skew. So the position of these two can be interchanged, the median and the mean. Okay, so now let's have a look at this example. So I have a data set of 1, 3, 5, 7, 7, 8. So this is already a range. So the smallest value is 1, the highest value is going to be 8. So if this data come from a population, so it's going to be mu equal 5.1667. If this data came from a sample, so my x bar is going to equal 5.1667. So when I wanted to calculate the median, okay, I'm going to take here I have even number 1, 2, 3, 4, 5, 6. So my middle number is going to be this 2, 5, and 7. So I'm going to add 5 plus 7 divided by 2. So that is going to equal a value of 6. And the mode is going to be 7 because 7 come out twice. This is 7, this is 7 as well, while the other numbers come out only once. So therefore the mode is going to be 7. So in terms of the shape of this distribution, so we got that mean is this number is actually less than the median and mode is the highest. So therefore it's going to be negative or left skew. So negative or left skew, that's actually the same thing but with different names. You can either use the term negative skew or you can also use the term left skew. Okay, properties of mean and median. So what is the difference and characteristic of mean and median? So mean is unique. Unique mean there can only be one value. Put over here, only one value. There could not be more than one mean value for a data set. There could only be one. So the mean is affected by extremely high or low value. So remember the outliers. So mean is also affected by outliers. So if you have a data set which has extremely high or low value, you might want to rule out mean, you might want to exclude mean, and you also need to exclude the mid-range, because those are not going to be a good way to represent the center of the data. The mean is used. Okay, so later we're going to have a look at variance, and in the formula of variance, so we are going to use the value from the mean. The mean cannot be computed for an open-ended frequency distribution. Open-ended frequency distribution means that you cannot tell what is the sample number. So you don't know what is going to be the end value. So therefore, if you don't have the end value, you cannot calculate the mean because you don't know what is going to be. So you're going to sum up the data, but you don't know what is going to be over what value. So the mean varies less than the median when samples are taken from the same population. So the mean is not appropriate average if the shape distribution is skew. So if you have a left skew or a right skew data, so please do not use mean. So I'm going to highlight, this is going to be very important. The mean is not appropriate average if the shape of distribution is skew. And you might want to take note of this when you do your assignment. If you have a skew data, don't use mean. Okay, median on the other hand is used when one must find the center or the middle value. Of course, it's a measure of central tendency. So the median will make sure that the data value fall into upper half or lower half of the distribution. The reason is that because when we have median, so we divide our data into two groups. So this group will be the lower half. So this group will be the upper half. So the median is affected less than mean by extreme high or low value. So that is why when you have outlier, so please use the mean. Let's have a look at this example. So actually this is similar to example 1.3, so for which we have data of 1, 3, 5, 7, 7, and 8. But for this particular example, what happens is that we add another value which is going to be 1. And compared to the rest of the data sets, 21 is an extreme value. It is extremely large compared to the other value, and it might be an outlier. So now we're going to have a look at if we were to have an outlier in the function, so how does it change the measures of central tendency? How does it change the mean, median, mode, and so on? Okay, so what happened is that, so when we calculate the value of this mean, so we get a value of 7.4286. So what is the previous value? So the previous value, when we don't have that value added, the value is 5.1667. That's a value of 2 units. So 2 units is actually kind of large. So what happened now, it becomes 7.4286. So that is why mean is easily affected by outliers. So if you have outliers, it may not be appropriate average to use. Okay, so don't use mean if you have outliers in your data set. So and then we're gonna have a look at median. So what happened is that previously, I think it's 7 as well. So the median value is no, it's not 7, it's 6. But now the new median is going to be 7. So that's not much difference, just a value of 1 unit. Okay, and meaning that median is not much distorted when we have an outlier value. It doesn't change too much. Okay, and the mode for this case is still going to be 7. The mode doesn't change. And the calculated mid-range is going to be 11. So previously the mid-range value is equal 1 plus 8, so which is going to be 4.5. So previously it's 4.5. Now the value of the mid-range become 11. So that is a really big change in terms of a value. That's a change of 6.5 units. All right. So therefore, mid-range and mean is not suitable when you have outliers. Okay, and for this case, the shape of distribution is positively skewed since mode is the smallest value as compared to the mean and median value. So we have seen this before. According to the how do we determine distribution from mode, median, and mean. So when mode is 7, okay, mode when we sketch, it's going to be something like this, and this is going to be 21. Along over here is going to be 7. So you're going to have a high frequency right there. So this is going to be right skew or positively skew. Okay, so that is going to be the case because mode value is the smallest compared to the other values. Right, so this extremely high or low value, as I mentioned before, so the name is called as being outlier, and that is actually a specific formula. So how do you tell whether it's outlier or not from a specific data set? Alright, so let's have a look at exercise 1.3.1 from the values of mean, median, and mode. So we are going to determine what is the distribution of the function. Remember, we have 3 type of functions, 3 type of distribution for our data set. So the first is going to be symmetric. So symmetric is when your data set actually looks something like this. And then you have the case of left skew. Okay, so this is going to be the case of left skew. So as what happened is that towards the left, so it's going to taper off. Okay, so that's how the graph looks like, and this is called as taper off. This is the term that we use. It becomes gradually smaller towards the left. And then we also have the other term, so which is called as right or positive skew. So for which our graph is going to look like this. Okay, so it's going to taper off towards the right hand side. So that is what is called as being right skew. Okay, and we can easily identify that as long as we know the value of mean, median, and mode. And the most important one is going to be the mode. As long as the mode is there, we can identify whether it's going to be right or left skew. Okay, for the first one, for A, we have the case that mean, median, and mode all have the same value, which is going to be 11. And we know that this is going to be a characteristic of a data that is symmetric. And for B, so we have mean equal 25, mode equal 13, median equal 17. So here mode is going to be the smallest. So we know that there's going to be a graph, it's increasing that way. So mode is represent the frequency, and this side of the graph actually represent frequency. When the frequency occurs at a low value, so your graph is going to look like this, it's going to taper towards the right. So therefore this is going to be the case of right skew. And the same goes for C. I have the opposite. So mean is equal 5, mode is equal 73, median is 17, for which my mode is going to be the highest. So mode occur at a very high value, so your graph is going to taper towards the left. So this is a characteristic of a left skew data. And the last one, so here the value of mean, median, and mode is not given, so meaning that you have to find them. How do you find the mean? So the mean can easily be done by using the calculator. You can either add them all, divide by how many numbers do you have, or you can actually plug in the value into your calculator and ask the calculator to produce the mean. So for this case, it's already written down here. Let's use the value straight away. The mean value is going to equal 12.88. You can verify that for yourself. You can add all these numbers together and then divide by the size of the data. So what is the size? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So add all these numbers and divide by 10 and you will get the mean. Or you can use this step that is provided in the slide on how you use your calculator in order to find the mean as well. So that would work. And then we're going to find the value of the median. So I've counted just now. We have 10 values in our data set. So where is going to be the middle values? The middle values is going to be right here. We have 4 on the left, 4 on the right. So the median is going to be this values divided by 2. So I'm going to have 12 plus 8 plus 13.3. And the sum of that is going to be divided by 2. And that is going to be a value of 13.05. No, that's an highlighter. I don't want this either. So it's going to be 13.05. And then we're going to find the mode as well. We know that the mode is going to be the one with the highest frequency. And if you notice, so I can easily find the median and mode for this case because it's already ordered. Remember, when you want to find mean and median, your data has to first be ordered. So this is already ordered from smallest to largest. And for the case of mode, I noticed that there are this number that come out twice, so which is going to be 13.3. So my mode value, that is going to be 13.3. And if you have a look at these values, I noticed that my mode is going to be the highest value. So it's going to be referring to this graph right here. So therefore, for this case, it's going to be a left skew data. Okay, and try to do this one as well, number 2. So you have this data sets. You have to arrange them first because this is randomly arranged. Arrange them to smallest and largest. So try to calculate that. And then probably we'll discuss this during our, online class. Okay.